So we have a derivative that's given to us. It's an f prime of x, and a lot of times we're given an f of x. Well, the fact that we're given an f prime, that we're given the derivative, it's going to make part of the problem a good bit easier. But I'm going to go through the three prompts that it asks you to do. Part A says, well, what are the critical x's? So I didn't have to find the derivative, it was given to me. So you give that function, you take the function that was given to you and set it equal to 0. Now, the derivative is rational. So when you set it equal to 0, think of that 0 as being 0 over 1, and you can cross multiply. So that 1 times the x squared times x minus 2 is just x squared times x minus 2. And then you have 0 times x plus 3, and you just get 0. So from there you can set x squared and x minus 2 equal to 0, and you get critical x's of 0 and 2. Now that we have our critical x's, we can figure out some increasing and decreasing. And on the number line, let's see if I can kind of put it out there. So 0 and 2 were our critical x's. So you see I put tick marks there, but I also put a tick mark at 3 because in the original problem, x could not equal 3. So I tested in between the intervals, in between the critical x values. So there was that interval between negative infinity and 0, and the interval between 0 and 2, and the interval between 2 and 3, and the interval between 3 and infinity. And I just chose a random x value in between those intervals, and you plug it into the derivative. Now, if the number on the interval that you choose, once you plug it into the derivative, if it gives you a positive number, you're increasing. So see, I chose negative 1 on that interval from negative infinity to 0. I didn't have to choose negative 1. I could have chose negative 5 or negative 1,000,000, just any number on that interval. And since it gave me a positive number, that positive 3/2, I know that I'm increasing. So you see where I drew that line. Then I chose a number between 0 and 2, and I thought the number 1 was pretty easy. I plugged that 1 into the derivative, and I got a negative. So I knew that I would be decreasing. From 2 to 3, I chose 2.5. Okay, I had to go with a decimal at that point. There was no whole number between 2 and 3, and I got a positive, so I was increasing. And you can see that I drew, let's see, well, hopefully I can make you see it. Between 2 and 3, I was increasing, and then 3 to infinity, I kept on increasing. Later on, in part C of the question, it asks about extrema. Well, because I was increasing from 2 to 3 and then kept increasing from 3 to infinity, that means that there are no extrema happening right here at 3. This is not a maximum or minimum at 3, is it? I mean, you just kept on increasing. But anyway, we can formally say that the original function is increasing from, let's see, negative infinity to 0, and from 2 to infinity. And we can say that it's decreasing from 0 to 2. And then that part C that asks about extrema, where relative extrema are at, we can see that there's a relative max right here at 0, because we went from increasing to decreasing. We maxed out at 0. So there's a max at x equals 0. And we can see a min at the critical value of x equals 2, because we bottomed out. We went from decreasing to increasing.